All right, thanks for your patience, guys. I know this has been a pretty long note sheet, but hopefully you're feeling okay with it. Two final problems to look at, and then that concludes the notes. For question 7, we should get x squared equals 81i, and we would take the square root. Yes, square root, meaning that we only have 2 solutions for this. I guess you don't have to put a little 2 there if you don't want to. So if we are going to find x, we're going to take 81i and raise that to the 1/2 power. So starting off, we would graph this, and remember that this is our imaginary axis, so we're looking at this value here. So we would get 81 kiss, and then we can call that pi over 2, all to the 1/2 power. Hey, Brooklyn, good morning. You want to say hi to my students?
Hi.
Okay. Oh, Spencer's here. Spencer, you want to say hi to my students? Come here, buddy. Say hi to my students.
Hi, students.
Aw, you're so sweet. Okay, so we are going to then do DeMauve's. So this is going to get really bad. 81 to the 1/2, kiss, pi over 2 times 1/2. So 81 to the 1/2 is 9, kiss, pi over 4, and that is our first solution. Now to find our next solution, remember equal spacing. We have 2 solutions and only 2 solutions for this problem, which means that if we were to take 2 pi and divide it by 2, each solution is pi units away. Shh, let's try to be quiet, okay? Can you be quiet for a moment? Each solution is going to be pi units away. So if you were to take pi over 4 and add pi, well, just think about going on the opposite side. Because remember, pi over 4 is here. Adding pi is just going to take you to the opposite side. So we are looking at 9 kiss, and this is going to be 5 pi over 4. Now, to get each of these in standard form, let's think about the first one. This is going to be 9 times the cosine of pi over 4 plus I sine pi over 4. So cosine of pi over 4 is root 2 over 2, as is the sine.
What are you doing?
I'm doing math.
Oh.
9 root 2 over 2 plus 9 root 2 over 2 I. Hey, did you guys go say happy birthday to Daddy?
Is he still sleeping?
Is he still sleeping? I don't know. Do you guys want to go check? Take your time. Go very slowly. And be. In just a moment, we'll talk. Shh. Yeah. Be shh. Good. And then for the 5 pi over 4, remember that we are in the third quadrant, so both of these would be negative. I have really cute kids, I'm telling you. And I'm not just saying that because they're my kids. They are really cute. So we get that second solution there. Final problem, and then I can go give my family some attention. You are going to find the 5 fifth roots. So again, we're finding 5 total solutions, but it says the roots of unity. The roots of unity is a fun expression. When you're talking about roots of unity, that means z equals to 1. In other words, you're talking about this right here. So if you were to write this in trig form, this idea of this being 1 kiss 0 degrees or 0 radians, however you want to think about that. But this is what the root of unity means. So that's what we want to find here. And we want to find the 5th roots of unity. Well, in other words, that means we're going to take 1 kiss 0, and we are going to raise it to the 1/5 power. Now, this seems very basic, and it really is, because 1 to the 1/5 power, so when we use DeMauve's, is going to be 1, and then when we take 0 and multiply it by a 5th, we just get 0. And that is our first answer. Now, to find the remaining answers, remember this idea of equal spacing. And you know what? I'm going to go degrees on this one because I feel like degrees works just as well. We're going to take 360 and we're going to divide it by 5 to find out how much these are equally spaced. And what is that going to be? So that's going to be 7. And then I'm going to have 2 degrees apart. So our next solution is going to be 1 kiss 72 degrees. maybe I should have done radians. Now I'm regretting this because now I have to do more math. Then I'm going to get 1 kiss, and then I'm going to add 72 to 72. So I'm going to get 144 degrees. And then from there, I'm going to add another 72. I should have done radians. Now I'm regretting it. 72, that's 6, and then 1, and then 216. And then we are going to have to do this one more time. So let's go red. And then we get 1 kiss. And then we get another 72 to this. Is going to give me an 8, 8, 288. Now, those would be your 5 different solutions. If they said standard form, obviously this first one, you can go about finding this because at 0, it's easy. I mean, right, we just talked about this already because actually that's technically how it started. When you took it and raised it to the 1/5 power, it didn't change it. So we already know that this is going to equal 1, which makes sense. 1 to the 1/5 power is 1, right? 1 to the 5th power is 1. So we can then look at our next answer. Now this one, you would have to get decimal answers for this because 72 degrees is not one of our nice angles. So if you were to go to your calculator and actually find this, you can make sure your mode is in degree, unless you kept yours in radian. And then what we can do is we could find the cosine of 72. So that would give us approximately 0.309 plus, and then we would find the sine of 72. And then that's going to give us 0.951i as that second solution. And then for the third solution, we could do the same thing, the cosine of 144. And we are getting this negative 0.809 plus, and then we could do the sine of 144. And that's going to give us 0.588i. And then we could keep going for 216. So cosine of 216. So negative 0.809. Ooh, we're seeing some symmetry there with the other answer. And then we're going to have the sine of 216. So this 0.588i. And then we have our final one, the cosine of 288. And so we're getting the 0.309 plus, and then we can get that sine of 288. So then minus 0.951i. So let me know if you have any questions, but even though these are decimals and rounded, if you were to take each of these and raise it to the 5th power, you should see that you get 1 as a result.